Assalamualaikum and good day. My name is Faris bin Yahya and this is my final year project titled Thermal Aging Effect on the Dielectric Properties of Ester Impregnated Paper. The main objective of this project is to study how thermal aging affects the insulation performance of ester-based paper compared to the traditional mineral oil through some tests, which includes dielectric spectroscopy and breakdown voltage, or we call it a BDV test. So this project involves hardware experimentation and data analysis using key tools such as fan oven, impedance analyzer, and AC high voltage test set. The first tool used is a fan oven, which serves as an alternative to a vacuum oven for drying and impregnating craft paper with oil. Although it lacks vacuum capability, it enables controlled thermal treatment. So I use the fan oven for aging, which I set the parameter, for example temperature to 80 Celsius and the aging days for 5 days. Then the oven stops automatically after the preset time. The second tool is the Hioki IM3570 impedance analyzer, used for dielectric spectroscopy. So it provides accurate measurements of relative permittivity and loss tangent across a wide frequency range. The third tool is the AC-DC high voltage test set for BDV test, which applies high voltage to determine the breakdown strength of the oil impregnated paper. So this test helps evaluate the insulation's electrical endurance. For dielectric spectroscopy, the samples were placed between electrodes and the data were collected over 201 frequency points from 50 MHz to 4 Hz, which I have set in the parameter. So the analyzer measured capacitance and conductance, which were used to calculate permittivity and tangent delta. The BDV test was conducted by submerging the paper in oil between the spherical electrodes. So the voltage was increased gradually until dielectric failure occurred. So the BDV were recorded to ensure the values are captured. So this is the example video of how BDV tests are recorded. The voltage was increased gradually and slowly until the breakdown occurred. Okay, so after the breakdown occurred, I have to decrease the voltage back to 0 and shut it off for precaution. So dielectric spectroscopy results show that the thermal aging caused noticeable changes in permittivity and loss tangent. As shown on the graph here, pH1 value are higher than MH1, which are mineral oil. For example, at high temperature, pH1 maintained better dielectric than MH1, which became burnt and brittle after just 2 days. So BDV results support this observation, with pH1 achieving 3.80 kV, while MH1 dropped to 3.42 kV, confirming that PFAE offers better thermal resilience. So this image shows the puncture hole after breakdown occurred. So these findings are validated against literature that reports ester oils offer higher fire points and environmental benefits but are more sensitive to moisture. So tools limitation. From the experiment, the fan oven lacks a vacuum function, which reduces impregnation efficiency and may leave residual moisture, while the impedance analyzer is sensitive to environmental interference and does not fully isolate external noise at low frequency, while BDV test is a destructive method, preventing repeatability on the same sample and also affected by sample positioning, oil condition, and the presence of air bubbles. Despite the challenges, each tool provided critical data for assessing the insulation behavior. In conclusion, the selected tools effectively support this project in evaluating the thermal aging effects on the dielectric properties. The impedance analyzer revealed how permittivity and tangent delta change across aging durations, while BDV tests confirm the electric endurance difference between PFAE and mineral oil. So this project demonstrates the strengths and limitation of each tool and highlights the importance of proper insulation material selection in high voltage transformer systems. Thank you.